class, so chapter 2 should still be a little bit of a review. We're going to talk about linear and quadratic equations. So section 2.1 is about properties of linear functions and their models. So a linear function is a function of the form f of x equals mx plus b. Its graph is going to be a straight line with slope m and y-intercept b. You may have seen this before as slope-intercept form. Friendly reminder, f of x really just means y. We just wanted to show that the function is defined in terms of x, which is our independent variable, and y is our dependent variable. So a linear function of the form f of x equals mx plus b has a domain that is all real numbers. Its range is what changes. Remember, if I have a constant function, so f of x, say, equals some constant c, then my range, which is all possible y values, is just going to be that c value. If I've got a positive slope or a negative slope, so if m is positive or negative, i.e. m doesn't equal 0, then the range goes from negative infinity to positive infinity. Functions that are not linear are said to be nonlinear. We're very creative in mathematics. What's good about linear functions and helps us identify them if we don't have their equation is that they have a constant rate of change. That rate of change is their slope. So the average rate of change for a linear function is their slope, which is the change in y over the change in x. You may have seen this defined before as y2 minus y1 over x2 minus xy. This is delta, and it means change. It's the Greek letter delta, and it means change. So this rate of change stays constant between any set of 2 points on the same linear function. Friendly reminder that the zeros of a linear function are its x-intercepts, or when f of x, which is y, equals 0. So we're going to go ahead and talk about the 3 different types of slopes. So I've got positive slope. That means my graph is looking like it's going uphill. We would say that function is increasing. Negative slope, that makes it look like my function is going downhill. That means my function is decreasing. If I've got zero slope, you kind of think if I was to put a bowling ball on this, am I attempting to draw a bowling ball? Okay, if I put a bowling ball, it kind of looks like a ghost. If I put a bowling ball, it's not going to roll, right? That function is constant. It's level. That would have been a better way to say it. So when it comes to constant increasing or decreasing linear functions, I can determine this from their slope. So here I have f of x equals 1/7 x plus 5. Its slope is 1/7. That's positive. So even though it's a fraction, this is an increasing function. If I have f of x equals 6, that's going to be a constant function. My slope is 0. If I have f of x equals negative 3x plus 4, that's a negative slope, so my function is decreasing. And if I have f of x equals negative 1/2, even though that is negative, it's still just a constant. So my slope is 0. I have a constant function. So now let's use our rate of change, i.e. our slope. Why is it zooming in like that? I.e. our slope to identify whether something is a linear function. So we're going to look at the change in y over the change in x and determine if these functions are linear or nonlinear. And if they are linear, we're going to determine the slope. So I've got my first 2 sets of points right here for number 1. I have, I'm looking at my change in y over my change in x. So I've got 4 minus 0 over 0 minus a negative 1. That gives me a 4 over 1, which is 4. Now we're going to change colors and pick our next set of 2 points. Okay, if I find a slope of 4, because slope is constant, this is going to be a linear function. So I look at my change in y over my change in x. So I have x minus 4 over 1 minus 0. Getting a little ahead of myself, 1 minus 0. So I have 4 over 1, which is 4. So this is a linear function. and its slope is 4. All right, let's take a look at example 2. We're going to change colors. So I'm going to compare two sets of points. Now here I've got some fractions. If you don't want to work with fractions, you don't have to pick the first 2 points. I could pick this set of 2 points, this set of 2 points, right? And then we could change colors, not to a highlighter because that won't work very well, and pick this set of 2 points. I don't have to deal with the fractions if I don't want to, which is really nice. So let's switch back to green. So I'm going to take my change in y over my change in x. That's going to be 2 minus 1 over 1 minus 0. So I get 2 over 1, which is 2. Then let's check out these 2 red points. If I've got 2 minus 1 is 1. I'm sorry, so I've got a slope of 1. Now in red, I have my change in y over my change in x. That's going to be 4 minus 2 over 2 minus 1, which is 2 over 1, which is 2. So this is a nonlinear function. It's actually an exponential function. This is f of x equals 2 to the x, and we'll talk about that later. Let's do a couple more examples. So I have x is negative 1 when y is 9, x is 0 when y is 9, and x is 1 when y is 9. I'm sure you can already tell me what type of function this is because my y value is unchanging. It's a constant linear function. Oh, so if you can look at it and see, okay, I don't need to calculate the difference I don't need to calculate the slope. I know what it is. Don't feel like you have to go through all the mathematics. The slope of this is 0. I'm going to show you why. Let's compare these first 2 points. Change in y over change in x, because we like to be thorough. I've got 9 minus 9 over 0 minus negative 1. That gives me 0 over 1, which is just 0. And if I compared the other 2 sets, I would find the same thing. I've got 9 minus 9 over 1 minus 0. Again, I get 0 over 1, which is 0. So this is a constant linear function with a slope of 0. All right, for our last example here, let's go ahead and pick a couple points. I'm going to compare these 2 points and these 2 points. Now again, you want to look at what your y is doing to kind of visualize what's going on. So I have a function that's like increasing. It goes from negative 8 to negative 3 to 0 to 1 and then back down to 0. A line can't do that. A line can't go from like negative 8 to 3 to 0 to 1 and back to 0. It's kind of doing like this curvy type thing, right? So we know this isn't going to be a linear function. Let me show you why. So let's compare our points in green first. So I've got 1 minus 0 over 1 minus 0. Oh, wow, that's kind of boring. Which is 1 over 1, which is 1, which is fine. Not all math has to be super exciting. Let's go ahead and compare the points in blue. I've got 0 minus 1 over 2 minus 1, which is negative 1 over 1, which is negative 1. Ah, right, that's not the same slope. So this is a non-linear function. And I'm pretty sure it's a quadratic. Like 99% positive. Let me drink more coffee and I'll let you know.